Okay, so in this video, we will learn about relation and functions. So on the board, we have here the definition of relation and functions, as well as the ways to represent our relation or functions. So here we have examples. So let us start. So first, let us define your relation. So a relation are any set of ordered pairs denoted by X and Y. Then the first element is called as domain. So this one, your X, will be your domain. And the second element is called the range, denoted by Y. Okay, so in some cases, your domain is known as your independent variable. And your range is your dependent variable. Okay? So, why do we denote our ordered pairs as X and Y? Because it is related to our Cartesian coordinate plane. That is, it's like here. Your Cartesian coordinate plane is also denoted by X and Y, your X-axis and your Y-axis. Okay? Then, let's proceed to function. Guys, we have to see to it. This one. So, our relation is composed of two, or we can make a diagram out of it. So, we have not functions and function. Or we can say that a relation can be a function or not a function. Okay? But we will be focusing, of course, to functions. So not all relations are functions. Some of relations are not functions. Okay? So we will be learning ways to identify whether a relation is a function or not using these things. Okay, so again, let's go back to the definition of your function. So a function is a relation such that each element in the domain corresponds to exactly one element in the range. Again, your domain is your X and your range is your Y. Okay, so simple. So let us proceed to ways to represent a relation or a function. So we have at least 5 on the board. We have the set of ordered pairs, table of values, then we have rule of correspondence or mapping diagram, then we have your graph, and last we have your equation. Okay, so let us proceed to the first one. First way to represent your relation or function is using a set of ordered pairs or ordered pairs. So we have 4 sets of ordered pairs. We have set A, set B, set C, and set D. So set A are made up or contains ordered pairs such as 1 and 2, 2 and 3, 3 and 4, 4 and 5. And B contains ordered pairs 3 and 3, 4 and 4, 5 and 5, 6 and 6. C contains 1 and 0, 0 and 1, negative 1 and 0, 0 and negative 1. And set D contains AB, BC, CD, and AD. Okay, so I will explain ordered pair set A. So we have each element of our ordered pair is composed of X and Y element. So the first element is your X. So the X here are 1, 2, 3, and 4. Or we can denote it as X sub 1, X sub 2, X sub 3, X sub 4. And the Y's are 2, 3, 4, and 5, or also known as your range, or y sub 1, y sub 2, y sub 3, and y sub 4. Okay? But using these ways to represent your function or relation, we can identify which are function or not function. Okay, so let's proceed to set A. So set A, function or not. So by definition, again, of your function, each element in the domain corresponds to exactly one element in the range. So to make it easy and simple, just identify or look at your domain or X. So your X or your domain are 1, 2, 3, and 4. Okay? So we can say that the domain corresponds to exactly one element in the range. So we can say that ordered pair set A is a function. Okay? Let's proceed to set B, or set of ordered pairs B. So we have 3, 3, 4, 4, 5, 5, and 6, 6. So identify your domain. So the domains are 3, 4, 5, and 6. So if you try to look at it, the domains do not repeat or corresponds exactly one element in the range. So ordered pair set B is also a function. Then letter C, we have 1, 0, 0, 1, negative 1, 0, 0, and 1. So the domains are 1, 0, negative 1, and 0. So if you will try to look at it, 0 and 0 repeats. So we can say that it is not a function. Okay? So simple. Let's proceed to set D. So we have A, B, C, and A as your domains. So if you can see, the domain A repeats. So we can say that it is not a function. So very easy to identify which is a function and not a function using your set of ordered pairs. Okay, let us proceed to number 2. We have here the table of values. So the table of values is also composed of your X and Y elements or variables, your independent and dependent variable. But we represent it using a tabular manner, or also known as table of values. Okay, so your X values or your domain are 1, 2, 3, 4, 5, and 6. Your range are 2, 4, 6, 8, 10, 12. So focus on your domain or X. So we can say that each element of your domain corresponds to exactly one element of your range. So we can say that this is a function. Okay? Your B. So the X or the domains are 4, negative 3, 1, 2, and 5. So not a single domain repeats. So we can say that it is a function. Okay? Then C, we will look at our X or our domain. We have 0, negative 1, 4, 2, and negative 1. So negative 1 repeats, and we can say that it is not a function. So very easy. Then let us proceed to number 3, role of correspondence or the mapping diagram. Continue our lesson on the ways to represent your function as well as your relations. So let us proceed to number 3, the mapping diagram or the rule of correspondence. So the first elements are the domain. So we have first elements of A, B, and C. And we have the rule of correspondence below. So we have 1 to 1, 1 to many, and many to 1. So we have diagram letter A. A corresponds to X, B corresponds to Y, and C corresponds to Z. So we have a 1-to-1 correspondence. Then, mapping diagram letter B. So we have X and Y as our domain, and range are A, B, and C. So X corresponds to A, X corresponds to B, and X corresponds to C. And let's proceed to mapping diagram letter C. The domains are Jenna, Donna, and Maya. The range are Ken, Mark, and Ray. So Jenna corresponds to Mark, Donna corresponds to Mark, and Maya corresponds to Mark. So diagram C, the rule correspondence is many to 1. B is 1 to many, and A is 1 to 1. So without much ado, so 1-to-1 correspondence is a function. Many to 1 is not a function. Many to 1 is a function. Again, 1-to-1 correspondence is a function. 1 to many correspondence is not a function. And many to 1 correspondent is a function. Okay, so if you want to check, the mapping diagram can be converted into your set of ordered pairs or table of values. So we will take diagram A. Let us convert it into set of ordered pairs. So we have A and X. Then we have B and Y. Then last we have C and Z. So your mapping diagram can be converted into set of ordered pairs as well as your table of values if you want to check. So the main rule here in identifying whether a relation is a function or not is to look at your domain. So it's okay to repeat your Y, but do not repeat the X. If so, that relation is not a function. Okay? Let us proceed to number 4. So number 4 is representing your function or relation using equations. So in some books, equations as a way to represent a relation or function is not emphasized. But it can be a way to represent a relation or function. Such as, example, f of x is equals to 2x squared plus 1. Okay? So this is an equation, a function that represents a relation, and this relation is a function. Okay? This one is an equation of your circle. So this equation or relation is not a function. Ay circle ni siya. Then we have y is equals to x plus 1 over x plus 2. So it is not emphasized on books that it is a way to represent a function or relation because it will be hard for us to identify whether this equation is a function or not. Okay, so the easiest way I think to identify this equation or relation as function or not is to graph or solve it using the table of values. Okay, so to make your graphing easy, you can download these apps. Okay, you can download GeoGebra or Desmos in graphing equations and functions. Okay, The last, we have graphing or graph. Okay, so we can represent a relation of function using a graph. Okay, so we have example A, B, C, and D. So in identifying whether a graph of a relation is a function or not is using your vertical line test. Okay, so a vertical line test says that a relation is a function if and only if it passes through at exactly one point. Exactly one point. If the graph passes through a vertical line test at not exactly one point, it is not a function. Okay, let us proceed to example letter A. So the graph of your function is a line. Okay, so if we will put a straight line here, or a vertical line, we can see that it passes through at exactly one point. Okay, if we'll put a vertical line here, you can see that it will pass through at exactly one point. So letter A is a function. Okay, let us proceed to letter B. So letter B, if we will try to put a vertical line in here, you will see that it will pass through at exactly one point. So letter B example is also a function. Okay, if you will put a vertical line in here, it will also pass at exactly one point. So it is a function. Let's proceed to example letter C. So letter C is a parabola that opens to the right. So if we will put a vertical line here, you can see that it will pass through at 2 points. 2 points. So your vertical line test says at exactly one point. So letter C is not a function. Okay? Then letter D. We will put a vertical line in here. You can see that it will pass through at 2 points. So it is not a function. So are we clear on that? So in summary, we have the definition of your relation, functions, and the ways to represent your function and relations. Okay? So that's it.